Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video. Multiplying fractions. This video will help you simplify a fraction, multiply two fractions, build equivalent fractions, and use a fraction to convert units of measure. Simplify a fraction. Let's start with some definitions. Equivalent fractions are written differently, but represent the same quantity. A fraction is in simplest form when its numerator and denominator have no common factors other than 1. Now let's take a look at some examples that will help us understand equivalent fractions and the simplest form of a fraction. Example 1. Compare the pictures for 9/18 and 1/2 below. Here you can see we have a picture of 9/18, and here we have a picture of 1/2. You can see from their pictures that 9/18 and 1/2 represent the same amount. Therefore, we say that 9/18 and 1/2 are equivalent fractions. They are equal in value, except they're using different numbers to describe this value. Of these two fractions, 9/18 and 1/2, 1/2 is the simplest form of the fraction. It's a lot easier to understand 1/2 of something than it is to understand 9/18 of something. So what we try to do is we always try to get fractions in their simplest form because it's easier to understand those fractions. Let's take a look at example 2. I'm going to simplify 9/18 in example 2. When I get done simplifying, I'm going to end up with the simplest form of this fraction, 1/2. Let me show you how to simplify this fraction. First thing we're going to do is we're going to use the factor tree to factor both the numerator and the denominator. So I'm starting with 9. I'm going to use my factor tree and get the prime factorization of 9. So I'm going to start with any two numbers that multiply together to give me 9. And I think right away 3 times 3. Well, both of those 3's are prime, so that is the prime factorization for 9. Now I'm going to do the same thing with 18. First two numbers that come to mind are 3 and 6. Well, 3 is a prime number, but 6 is not. So I'm going to go ahead and factor 6 again. And when I factor 6, I get 2 and 3. So there is my prime factorization for 18. Now I'm going to go back to my fraction, 9/18, draw a big fraction bar, and I'm going to write the prime factorization for each of these numbers. Well, for 9, that was 3 times 3. And for 18, I had 3 times 2 times 3. Now what I'm going to do is I'm going to look for common factors in both the numerator and denominator and divide these common factors out. So you can see with the 3, we have a 3 in common, so I'm going to divide a 3 out of the numerator and the denominator. We also have another 3 in common, so I'm going to divide that 3 out of the numerator and that 3 out of the denominator. Now, it's important to remember that I'm dividing these factors out. So every time I divide these factors out, 3 divided by 3 is 1, 3 divided by 3 is 1. There's a bunch of little 1's left that I'm going to need to include in my simplest form of the fraction. I'm going to come down to my next line here. What I'm going to do now is multiply the factors that are left. Well, in the numerator of my fraction, I have 1 times 1, and 1 times 1 is just 1. In the denominator, I have 1 times 2 times 1, or just a 2 left, and so the 2 is in the denominator. And you can see that when I simplify 9/18, I end up with 1/2, the simplest form of these fractions. Now it's time to check your understanding of equivalent fractions and the simplest form of a fraction. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 1. Compare the pictures for 6/18 and 1/3 below. 6/18 and 1/3 are equivalent fractions. 1/3 is the simplest form of these fractions. Question 2. Simplify 6/18. First thing we're going to do is come over on some scratch work and get the prime factorization for 6. That is 2 times 3. Now we're going to get the prime factorization for 18. Thinking 3 times 6 to start. 3 is prime, 6 is not, so we factor 6. 2 times 3, there's the prime factorization for 18. Now we'll take our original fraction, 6/18, draw a big fraction bar. When I factor 6, I get 2 times 3. And when I factor 8, I get 3 times 2 times 3. Now I'm looking for common factors. They both have a common factor of 2. They also have a common factor of 3. So remember, when those factors divide out, we're left with little ones everywhere that we divided these numbers out. So in the numerator of my fraction, I'm left with a 1, and in the denominator, I'm left with a 3. So when I simplify 6/18, I get the simplest form of that fraction, which is 1/3. Multiply fractions. When we multiply fractions, we use a procedure that is very similar to simplifying fractions. Let's take a look at an example so you can see what I'm talking about. Example 3. In example 3, we're asked to multiply 2/3 times 9/10. When we multiply fractions together, we multiply straight across, numerators times themselves and then denominators times themselves. However, I don't want to multiply these numbers together yet because that's only going to create more work. What I want to do instead is factor and simplify as I multiply these fractions together. So going across with the numerators here, the first number I run into is a 2. Well, 2 is a prime number, so it's already factored. The next number I run across in the numerator is a 9, and that is not a prime number, so I'm going to factor that 9, and that factors into 3 times 3. Now I'm going to do the same factoring in the denominator. Going across the denominators, 3 is a prime number. 10, however, is not, so I factor 10, which is 2 times 5. Now what I'm going to do, just like when I simplified, is to look for common factors in the numerator and denominator. Well, they each have a 2 in common, and they also have a 3 in common. So I'm going to divide those factors out. So when I multiply 2/3 times 9/10, I get a final simplified answer of 3/5. Now it's time to check your understanding of multiplying fractions. Hit pause on your video player and answer the guided practice question. When you're done, hit play to see how you did. So we need to multiply straight across. However, we're going to save ourselves work if we factor as we go. So in the numerator, I'm going to factor the 4, which is 2 times 2. The 3 is already prime, so that's just going to stay 3. In the denominator, 6. When I factor that, it's 2 times 3. When I factor 10, it's 2 times 5. Okay. Now I'm going to look for common factors. Well, it looks like they have a pair of 2's, another pair of 2's in the numerator and denominator, and also a pair of 3's in the numerator and denominator. Now, you may think that all of those factors in the top have divided out, which they have, but remember, every time I divide these things out, I'm left with a little 1. So in the numerator, I have 1 times 1 times 1, or just 1. In the denominator, I don't need to worry about those 1's because multiplying that 5 times a bunch of 1's, it's still going to remain 5. So in the denominator, I have 5. So when I multiply 4/6 times 3/10, I get a final simplified answer of 1/5. Build equivalent fractions. Fractions equal to 1 have the same numerator and denominator. These fractions are very important, and we will use them often. Here we will use them to build equivalent fractions. We can multiply 3/5 by a fraction equal to 1. In this case, 2/2. To build the equivalent fraction, 6/10. So starting with 3/5, I can take this fraction and multiply it by a fraction equal to 1, in this case 2/2, to get the equivalent fraction 6/10. Now, both 3/5 and 6/10 are equal in value because all I've done essentially is taken this 3/5 and multiply it by a value that's equal to 1, and when we multiply by 1, we don't change the value of 3/5. Now let's take a look at an example that will help us understand how to build equivalent fractions. Example 4. Build equivalent fractions. We're starting with the fractions 3/4, and we want to end up with a denominator of 8. Well, we're going to have to multiply this fraction 3/4 by a fraction that's equal to 1 with the correct numbers in the numerator and denominator. Well, if I'm starting with 4 and I want to multiply by something to give me 8, the number that I'm going to need is 2. Now, if I'm multiplying the denominator by 2, I need to multiply the numerator by 2 so that I make sure that I'm multiplying by a fraction that's equal to 1 so I don't change the value of 3/4. And when I multiply the numerators together there, 3 times 2 gives me a new numerator of 6. So the fractions 3/4 and 6/8 are equivalent fractions. Now it's time to check your understanding of building equivalent fractions. Hit pause on your video player and answer the guided practice question. When you're done, hit play to see how you did. Question 4. Build equivalent fractions. We're starting with 4/5 and we want to end up with a denominator of 30. So we ask ourselves, 5 times what is going to give us 30? Well, the answer is 6. And if I multiply the denominator by 6, I want to multiply the numerator by 6 as well, so that I make sure I'm multiplying by a fraction that's equal to 1. When I multiply the numerators together, 4 times 6 gives me 24. So 4/5 and 24/30 are equivalent fractions. Use a fraction to convert units of measure. Let's start with a definition. A units fraction contains units of equal measures in the numerator and denominator. Units fractions are equal to 1. We use unit fractions to convert from one unit of measure to a different unit of measure. For example, we could use a units fraction to convert 7 yards into feet. Now let's take a look at some examples that will help us understand how to use a units fraction to convert units of measure. Example 5. Using the fact 3 feet equals 1 yard, identify the two units fractions that convert between feet and yards. Well, our units of equal measure are 3 feet equals 1 yards. I can put these units of measure into a fraction two different ways. 3 feet over 1 yard and 1 yard over 3 feet. Example 6. Identify the units fraction needed to convert 7 yards into feet. Notice I'm starting with 7 yards. That is my original unit of measure. So I want to choose a units fraction that has yards in the denominator. We always want to put our original unit of measure in the denominator. So I'm going to choose this units fraction here. 3 feet over 1 yard. Example 7. Use the units fraction identified above to convert 7 yards into feet. I start by writing 7 yards over 1 to make that unit of measure into a fraction. Now I'm going to choose my units fraction from above, 3 feet over 1 yard. Now I'm going to go to multiply these two fractions together. Well, units of measure can divide out in the same way that common factors divide out. And you'll notice that I have yards in the numerator and I also have yards in the denominator. Those two units of measure will divide out just like a common factor. Now notice all we have left as far as unit of measure in my fractions here is feet. And that's good because that's what I want to have in my final answer. Now let's multiply the numerators together. In the numerator I have 7 times 3 feet. In the denominator I have 1 times 1. That gives me 21 feet over 1. And remember, any number over 1 is just that number. Well, that works for units of measure as well. So 21 feet over 1 is just 21 feet. So when I convert 7 yards into feet, I get an answer of 21 feet. Now it's time to check your understanding of using a units fraction to convert units of measure. Hit pause on your video player and answer these 3 guided practice questions. When you're done, hit play to see how you did. Question 5. Using the fact 2 cups equals 1 pint, identify the 2 units fractions that convert between pints and cups. Well, I can choose 2 cups over 1 pint, and I can choose 1 pint over 2 cups. Question 6. Identify the units fraction needed to convert 6 cups into pints. Since I'm starting with cups, I want the units fraction that has cups in the denominator. So I choose 1 pint over 2 cups. Question 7. Use the units fraction identified above to convert 6 cups into pints. So I put my units fraction, 1 pint over 2 cups, into the framework, and you'll notice that my old unit of measure, cups, will divide out, one in the numerator, one in the denominator. When I multiply across, I'm left with 6 times 1 pint in the numerator and 1 times 2 in the denominator. I need to simplify this fraction, so I'm going to go ahead and factor the 6 in the numerator since it's not prime. When I factor 6, I get 2 times 3, and I still have 1 pint. And in the denominator, I have 1 times 2. Divide out a common factor of 2, and it looks like I have 3 pints in the numerator over 1 in the denominator, so I'm going to get a final answer of 3 pints. If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.